Hi, now let us deep dive into the bifunction function interface. Let us see where it comes from. It is part of the Java standard function interfaces and it was introduced in Java 8. Actually, it extends the idea of function to two inputs. So, what is bifunction? It is a function that takes two inputs, T, U, and returns a result R. So, input 1 plus input 2 and it gives an output. So actually it is used for combining data. So the core method available inside the bifunction functional interface is apply. Again it takes two inputs T, U and returns the output R. Let us see our school context. Bifunction integer and also gives the output integer total marks. It takes m1 m2 and returns the total of m1 m2. Total marks apply 40 50. It gives the result of 90. So it represents the integer, it represents the integer and the output represents the integer. So we should be thinking of like this: combine two values and produce something. So what is bifunction? Again, it is a functional interface. When it is used to take two inputs and transform them into a single output, just like we have seen, right? Here we are taking two inputs, marks 1, marks 2, and transforming them into a single output. Marks 1 plus marks 2, single output. So why it exists? Why bifunction functional interface exists? So let us see the scenario of in our necessity in our school context. We often need to add a student with fee and that returns the payment status. And also marks, student marks plus attendance that returns the grade and student along with student object along with course that returns the enrollment. So without bifunction, logic is not reusable. So with bifunction, you can have this logic reusable and it is working in pipelines. So let us see the functional programming perspective. It is a two-point transformer, two input transformer. It combines two sources, produces one result. Can be composed. You can apply chain. So let us see the passing bifunction. Here we have method public static method that returns int. The method name is calculate. It takes a b of types int as input parameters and also fn of type by integer by function integer. What it returns? It returns fn dot apply a comma b. So Here we are passing the bifunction 40 50. Here we are passing bifunction a comma b lambda operator a plus b. So composition. We have built-in method available inside the bifunction functional interface, that is and then. It transforms result further. So first we have a bifunction of type integer, integer, integer. The variable name is sum. It gives the output of a plus b. And then to grade, we have functional interface of integer string. It gives the grade if total is greater than equal to 40, pass, or else fail. So we're applying composition on top of sum and then grade. Because we are giving the inputs of 20, 30, the result is pass because it is greater than or equal to 40. So bifunction mental model, combine and then continue processing. So bifunction combine and then continue processing. It transforms further. We have real world usage patterns in our school modules like grade calculation and fee calculation, enrollment logic, and combining data streams like this. Just like we have seen in consumer functional interface and supplier functional interface, in functional interface also we have primitive specializations. So instead of bifunction integer, we can use int binary operator Marx addition. For Marx addition, we can use this primitive specialization of bifunction functional interface. So long binary operator IDs, double binary operator P calculations. So example for int binary operator is it takes two inputs and transforms like this. So let us see the internal working. When you write bifunction integer f is equal to a comma b followed by lambda operator a plus b, it converts lambda into functional interface. It converts this lambda into functional interface and uses invoke dynamic. It uses invoke dynamic and it gives efficient execution. So conceptual equivalent. When we write like this, actually it internally converts into anonymous inner classes. Bifunction integer and it overrides the apply method available inside the bifunction functional interface. So these are the common pitfalls or complicating logic like this, and using the bifunction for side effects. So for side effects, what we need to use is we need to use supplier functional interface. So here need to use by consumer instead. So confusing with function. Function interface has one input, but bifunction interface has two inputs. That is the difference. It also transforms, bifunction also transforms, bifunction also transforms, but function takes only one input and it gives the output. It goes the same with bifunction interfaces except for taking two inputs. This is a hands-on demo. So let us see the mental model. We should be thinking of a bifunction as a combiner. So if you see our school system context, it is like a decision maker. So it sees the marks and attendance. So and gives the result. It takes the fee and discount and gives the final fee. And also student plus course, it gives the enrollment. So bifunction is taking two inputs and it is returning one output, like T, it is taking T, U and returns R. So it is used for combining inputs. Core method available inside the bifunction interface is apply. So it also supports composition. The method for composition is and then. So why it is used? For transforming further. So what is it ideal for? It is ideal for calculations, rule evaluation, and data merging. That is the creative package with the name BiFunction function interface. Let us create a class with name BiFunction demo. So what we'll have in inside this class, we'll have main method by function. It takes two inputs, integer, and gives the output integer total marks. Let us import this. This is equal to, so marks 1 plus marks 2 marks 1, marks 2, marks 1 plus marks 2. So on top of this total marks, where applying the apply method, and let us give the marks 40, 50. So it should produce the result of 90. So marks, total marks obtained, total marks obtained. Let us try to debug this. Keep a breakpoint over there. So total marks obtained is 90. Now let us see the passing of BiFunction. Passing BiFunction demo. Okay, main method. Outside of the main method, what we'll have? We have private static int calculator to take int A, int B, and BiFunction or integer. Let me write it here. BiFunction of integer fn. So we are returning fn dot returning sorry. And then fn dot apply a comma b. So now we are calculating. We're calling the calculate method. Now we are passing the BiFunction 40, 50 and behavior A, B. That should return A plus B. Let us hold this value inside the local variable. Variable name is total marks. Let's keep a breakpoint here. Try to debug this. So total marks are 90. 40 plus 50, 90. Let us see the composition now. Composition BiFunction demo. What we have inside this? We have main method. First, let us see the sum of the marks. BiFunction integer sum is equal to, it takes two inputs, marks 1 comma marks 2 returns the sum of these marks 1 plus marks 2, and then our focus now is to calculate the grade. This time we'll take function. It takes integer as an input and returns the string as an output. To grade is equal to total marks total greater than or equal to 40. Assume that pass marks are 40. If total greater than or equal to 40, then pass, or else fail. We are using ternary operator here. Now let us apply the composition now by function. So we should take two inputs, integer for marks, and then for grade we should take output, and variable name is result is equal to sum, and then to grade. Now let us utilize the apply method. So what are the marks? Let us see first. Let us see 20 and 10. Grade. Let us keep a breakpoint here. Let us try to debug this. F8. So here result is fail. Why? Because he has got only 30 marks. Now let us assume that this person has got more marks. 40. So total marks now becomes 60. So he should pass, right? Let us delete this again. Let us debug this. F8. Now pass. Why? Because he has got 60 marks. Now let us see the conceptual equivalent. Conceptual equivalent BiFunction. So what we have main method inside this class. Fine. By function integer that returns output integer Let us give the variable name total marks is equal to new by function. Actually, it is equivalent to this anonymous inner class. So basically, if we write so it should give return integer marks 1, marks 2, marks 1 plus marks 2. Total marks dot apply 40, 50. Marks obtained. So 90. Here, what I mean to say is if you write by function integer, 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 let us say total is equal to new marks 1, marks 2 should be marks 1 plus marks 2. So this is what we have done, right? So it is conceptually equivalent to this thing. Internally, it uses anonymous inner classes. So we can avoid this.